Assalamualaikum. Samad Yaseeen, lecturer chemistry. BS स्टूडेंट्स, आज हम केमिकल काइनेटिक्स के चैप्टर में स्टडी करेंगे फर्स्ट ऑर्डर रिएक्शन एंड देन सेकंड ऑर्डर रिएक्शंस. Students, as you can see, the substance A is decomposing into a product. If we suppose that when the reaction is not starting, time is equal to 0, mean reaction is not start yet, then reactant does not decompose and number of mole of A is as represented by A moles. This is the initial concentration of A, and after the time T, when the reaction has got started and T time has been left, then you can see that X amount of moles of product have been formed. So remaining mole of reactant A is A minus X moles per dm cube. So according to law of mass action, we can say that rate of reaction at time t depend upon the initial concentration remaining. मेन मतलब ये हुआ कि लॉ ऑफ मास एक्शन के मुताबिक टाइम टी के ऊपर जो रेट ऑफ रिएक्शन है वो डिपेंड करेगा जितनी अमाउंट ऑफ रिएक्टेंट रह गई है पीछे, जो कि A माइनस एक्स है. लिहाजा dx by dt, that is rate, is directly proportional to A minus x remaining concentration left behind of a reactant. When you replace the proportional sign with equal constant came, so dx over dt is equal to k into A minus x. Here k is the rate constant for the first order reaction. This equation number 1 tell us that what is the rate of diminishing or decomposing the substance or reactant A. We want to find such an equation which can tell us not only rate of decomposing or diminishing of the reactant, but also the rate of formation of product X at the time t. So to get the equation which can tell us the product as X at any time t, we have to integrate the given equation number 1. So for integration of this equation, we have to separate the variables. We have to take the A minus x variable to the left hand side and dt variable to the right hand side. So equation will be formulated as dx over A minus x is equal to k dt. We have just rearranged the equation number 1 as before. So now put up the integration sign from the both side of equation. Constant remains outside of integration as k is outside the integration sign. You can see that dt when integrate it give us t, so it become kt plus constant c is showing the constant, which is the constant of integration, while on the left hand side you can see that dx over A minus x, when integrate it give us the result as minus ln A minus x. Here you can see in the lower step how dx over A minus x after integration give us ln A minus x into minus 1 is equal to minus ln A minus x. Mean actually it is the integral formula law. When we take the integral of 1 over x into dx, it is equal to log of x. Similarly, we have taken A minus x instead of x, so it will become log of A minus x with minus 1 multiple, that is coming from the formula, so it will become minus ln into A minus x. Here c, which is present in equation 2 after integration, is the rate integration constant after coming the integration. So in order to find the value of c of this constant, we have to put some boundary conditions. If we put the initial reaction boundary conditions at the start of the reaction, when time is equal to 0, mean reaction does not start and does not perform any product, then x is equal to going to be 0 because x is product. So put up t is equal to 0 and x is equal to 0, hence kt factor becomes 0 and remaining factor is minus ln a is equal to c. So this is the value of c is equal to minus log of minus ln a. Minus ln is actually natural log. So put up the equation 2 and now what you have, find the value of c, put equation c in equation 2. So it will become minus ln a minus x is equal to kt minus log of a. Now multiply the equation with negative sign -1, you will find ln a minus x is equal to minus kt plus ln a, means every quantity sign is going to be reverse, plus become minus and minus becomes plus. So we have find out this equation in the form of straight line equation, which is y is equal to mx plus c. Here the two variables ln a minus x is showing y and t is representing x variable. So t is an independent variable, it will be drawn on the x-axis, and log of a minus x is a dependent variable, it will be drawn on the y-axis. When we have draw a graph between these two variables, we will see that straight line will be formed, and this straight line will have a negative slope in the form of k. So slope of any line is equal to tan theta. And similarly, the intercept of the previous equation will be log of or ln a. Now equation 4 can be rearranged in the form of first order equation. Mean different forms of first order equation can be rearranged by the same equation. Now we will going to rearrange it into another form. For example, previous equation number 4, log of a minus x is equal to minus kt plus log of a. We are going to take natural log on the left hand side. So log of a is going to right hand side to left hand side, it will become plus log on a to minus log of a. So log of a minus log of a minus x is equal to kt. Now you have just multiply with -1 to the whole equation, so the signs are going to be reversed. Now after applying the formula of log of a minus log of a minus x is going to form log of a over a minus x is equal to kt. Now it is another form of straight line equation, y is equal to mx plus c, where constant is 0. We are going to plot a graph between the dependent and independent variable. So on the x-axis independent variable t is going to be plotted, and on the y side log of a over a minus x, if it is dependable variable in this equation, is going to be plotted. So as a result, straight line will be obtained which is passing through the origin of this graph, and it have the positive slope that is in value of k. So slope of the line is k, that is tan theta, and here the intercept is 0 because it is passing through the origin. Now we can arrange similar equation another form in the common logarithmic form. So to convert the natural log to the common log, we have to multiply the natural log into by 2.303 factor. So multiply the above equation with 2.303 natural log will be converted to common log. So 2.303 log a over a minus x is equal to kt. Now you could rearrange it, taking the 2.303 factor to the right hand side. Equation becomes log a over a minus x is equal to k over 2.303 into t. So again equation number 6 becomes this straight line equation where y is equal to mx plus c, where constant is 0. So again you can draw this straight line equation in the form of graph where independent variable t is plotted on x-axis and log of a over a minus x is plotted on y-axis. Straight line will be obtained passing through the origin where the slope will be positive. Value of k over 2.303 is the value of slope, is equal to tan theta, and intercept here is 0 because the line is passing through the origin. Similarly, the exponential form of first order equation can be formed by rearranging these equations and so take the equation 5 log of a over a minus x, which is natural log of a over a minus x is equal to kt. If we take the equation number 5 and take the anti-log of this equation on the both hand side, then the natural log will be cancelled with the anti-log and remaining factor will be a over a minus x is equal to e raised to power kt. So students, always remember that whenever you take the anti-log, the quantity present over the right hand side, it will become the power of base of natural logarithm. We can also say that natural logarithmic base value raised to power this quantity kt. So now invert this equation. A over a minus x is, when inverted, it is going to form a minus x over a is equal to e power raised to minus kt. Mean after inversion its sign is going to be reverse, plus to negative. Hence a minus x is equal to a into e raised to power minus kt. It is an exponential form of first order equation, and you can write this exponential form of first order equation in also common logarithmic form when a minus x is equal to a e raised to power minus kt divided by 2.303 factor. Students, concentration of reactant a minus x left behind can be determined. We can know the concentration which is present initially and the time to reach that stage. मतलब कि initial concentration कितनी present थी और उस स्टेज पर पहुंचने के लिए कितना टाइम दरकार है. अगर आपको ये चीज़ें पता हों तो आप कंसंट्रेशन जो रिएक्टेंट की बाकी रह गई है उसको निकाल सकते हैं. सो नेक्स्ट हेडिंग इज यूनिट ऑफ फर्स्ट ऑर्डर रेट कांस्टेंट. Here you can see that equation number 5 log of a over a minus x is equal to kt. You can rearrange the equation to get the rate constant on one hand side, and so equation will become k is equal to 1 over t log of a over a minus x. As you know, a is an initial concentration, a minus x is a remaining concentration. Both are the concentration, so its unit will be mole per dm cube. These units will going to be cancelled and unit of time is second, and when it goes to the upper side it will become per second. So rate constant of the first order reaction can be expressed in per second, per minute, per hour, and so on. Similarly students, half-life period of first order reaction. Next heading is half-life period of first order reaction. Students, half-life period of first order reaction is the time required to convert half of the reactant to the product. मतलब कि इनिशियल जितनी भी रिएक्टेंट की अमाउंट प्रेजेंट है उसकी इनिशियल अमाउंट को हाफ करने के लिए, हाफ रह जाने के लिए कितना टाइम दरकार होगा, उसको आप कहेंगे हाफ लाइफ पीरियड। और हाफ लाइफ पीरियड मोस्टली रिएक्टेंट पर और रिएक्शन की कंडीशंस के ऊपर डिपेंड करता है। मिसाल के तौर पर जैसे हम जानते हैं कि N2O5 अगर डीकम्पोज हो तो उसके नतीजे में नाइट्रोजन डाइऑक्साइड NO2 और ऑक्सीजन गैस बनती है। If this reaction is going to be carried out at 45 degrees centigrade, then half life for N2O5 is 24 minutes. It means after 24 minutes, whatever the amount of N2O5 is initially present, it will going to be reduced one half. For example, 1 mole of N2O5 is present initially, then 0.25 mole is going to be transferred into product, and 0.5 mole of N2O5 is going to remain after 24 minutes. And similarly, in the next 24 minutes, remaining 0.5 mole is going to be reduced one half, and 0.25 mole left behind, and 0.25 mole is going to convert it into products. As a result, in 48 minutes, 0.75 or 75% of N25 is going to be decomposed, but 25% or 0.25 N2O5 is also left behind after 48 minutes. So we can say, in other words, it will take many days to convert N2O5 completely into product. As the days are going to pass by, the remaining amount of N2O5 is going to decrease. To find out the equation for the half-life period for the first order reaction, we have to put up T is equal to T half and X is equal to A by 2. Mean where T is present, replace it by T half and replace X by A by 2. So equation 5, log of A over A minus X is equal to KT. We are going to separate T on the left hand side, and the equation will be formed 1 over K log of A minus X. In this equation, put T is equal to T half 1. So equation will become T is equal to, when we are putting T is equal to T half, so equation will become T half is equal to 1 over K log of A over A minus X की जगह यहाँ पर A by 2 पुट कर दिया. So आप देखेंगे as a result A minus A by 2 is equal to A by 2. When A and A is going to be cancelled, so remaining equation will be 1 over K log of 2. Log of 2 is equal to 0.693. So final equation is T half is equal to log of 2 over K, which is log of 2 0.693. So T half is equal to 0.693 over K. So according to this equation, half-life period of first order reaction is inversely proportional to the rate constant of the reaction and independent of the initial concentration of a reactant. मतलब कि हाफ लाइफ है जो फर्स्ट ऑर्डर रिएक्शन की, वो रेट कांस्टेंट के तो इन्वर्सली प्रोपोर्शनल है, लेकिन वो इनिशियल कंसंट्रेशन के ऊपर डिपेंड नहीं कर रही. Students, now the examples of first order reaction. Very first example of first order reaction is, as we have discussed before, N2O5 nitrogen pentaoxide is going to converted or decomposed into nitrogen dioxide and oxygen gas. The progress of this reaction can be measuring the volume of the oxygen gas at different times. Let's say Vt is the volume of the oxygen at the time t, so V infinity will be the final volume of oxygen and the reaction will be completed. So we can say that N2O5 have the initial concentration A. This initial concentration A of N2O5 will be considered as V infinity, and the remaining concentration of N2O5 will be considered as V infinity minus Vt. So the first order equation can be written as K is equal to 1 over T log of V infinity over V infinity minus Vt. So if different volumes V naught, V infinity, Vt are known, then the value of rate constant K can be calculated. Likewise, students, decomposition of hydrogen peroxide H2O2 in aqueous solution and in the presence of platinum catalyst, it will be converted into water and atomic oxygen. The progress of the reaction can be monitored by the standard KMnO4 solution, as KMnO4 solution is going to react with hydrogen peroxide in oxidation reduction reaction. Similarly, hydrolysis of ester ethyl acetate on acid hydrolysis will yield us acetic acid and ethanol. So the progress of this reaction can also be determined by volumetric titometric analysis, acid-base titration, where the quantity of acetic acid produced with the passage of time can be found out by titrating with a base sodium hydroxide. As more and more volume of sodium hydroxide is going to be used and considered with the passage of time, means the reaction is progressing further. Similarly, inversion of sugar cane, sugar sucrose, normal sugar C12H22O11 on acid hydrolysis can be converted into glucose fructose C6H12O6, and the progress of the reaction can also be found out by noting the optical rotation of the reaction mixture. Thank you.